I hope everybody had a nice weekend. Hopefully, you're able to relax a little bit, enjoy some time with your families. Hopefully, you're able to get outside with some of this nice weather. I know I was able to, and getting that fresh air definitely helped, especially after being cooped up for so long. So, the as I said going into this, since everything is new to all of us, this whole online schooling, things are going to change, right? We have to be able to adapt as we move along. So, some of your parents may have received an email from the superintendent, and the superintendent and a bunch of principals met and tried to come up with something. Because they felt like a lot of parents and students may have been overwhelmed with this whole new online schooling. I know I certainly was as well. So what they decided to do, this decision was district wide, is to kind of lessen the workload a little bit. So what that means is what we're going to be doing, at least the intermediate schools. Monday and Wednesday are going to be all with Miss Matola. So that means that you guys are going to be doing your language arts and social studies with her on those 2 days. My days are going to be Tuesdays and Thursdays, right? That's what we're going to be doing math and science. So hopefully this will make everything a little bit easier for everyone. That doesn't mean on Mondays and Wednesdays that I'm not going to be accessible, right? I'm still going to be on Google Classroom. I'm still going to be answering questions for you guys. Maybe if you guys have any questions about problems, kind of like what I'm going to be doing right now, I can make some videos to help you guys through that. So that would be a good opportunity for you to send me an email and be like, hey, I really need help with so and so problem. Can you make a video, right? So that would be a good opportunity, an opportunity for that. So for example, the problem that you see in front of us is a problem that Lily brought to my attention that was difficult, and I completely get why this might be a challenge. So this problem is very similar to the problems that we did with numbers like 1 and 2. And there's only one problem in the textbook that was actually really similar to this that I did show a brief video about, but I think it's important for me to go over this again because it is definitely a difficult concept. So the question is this figure to the right. Okay, so this figure to the right is 2.5 centimeters by 2 centimeters and then 1 centimeter high. So they're not asking for the volume of this. They're asking how many of these half-inch cubes can fit into this figure. And this can be a little bit challenging. One way is you can find the volume of this, and then divide to figure out how many times it fits in. The easier way that I found is, well, figure out how many of these half-inch cubes fit along the length, how many fit along the width, and how many fit along the height. So I'm going to show what that looks like here with this cube here. So before I show it with the actual problem, I'm going to show how many of these half-inch cubes can fit into this 1 cubic centimeter. So this cube, right, how many of these can fit along this 1 centimeter mark? Well, half a centimeter plus a half a centimeter equals 1 centimeter. So this would be a half, this would be a half. So 2 halves can fit into that one. Then how many can fit along the width? Well, there's a half and a half. 1/2 plus a half is equal to 1. So if you think about it, the way that it would look across the bottom would actually look like this. Okay, so it would look like this. So there's 1, 2, 3, 4 boxes of these boxes that can fit along the bottom. And then so there's 2 along the length, 2 along the width. Now along the height, there's another half here. So 2 halves can fit into 1. So what that would look like if we were to make a visual, it would, my drawings aren't perfect, but it would look kind of similar to this. And you can even show the base. I know it may look a little bit complicated, but there are technically 8 of these squares that can fit into that. The easier way to do that than trying to draw this and figure out what that looks like, if there's 2 along the length, 2 along the width, and 2 along the height, we can find it out by doing 2 times 2 times 2, right? Length times width times height. Okay, that's the volume. So the volume is going to be, well, 2 times 2 is 4 times another 2 is 8. So that means 8 of these 1/2 cubes can fit into this. Now, that's how you do it in a problem like that. But what would that look like with this? So, how many of these 1/2-inch cubes can fit along this half? So, excuse me, along this length. So, if you think about it, right along the length, okay, there are 2.5 inches. So, let me just show that. So, let's say that these are 2 inches. And this is a half. Okay. So 1/2. Oh, I'm sorry, I did this wrong. I was thinking about actually 1/4 inches. So that's my mistake. Okay, so if you think about how many halves fit into 2.5. Okay. So 2 inches. So let's just say this is 1 inch. Okay, and then this is 2 inches, and then that's a 1/2 inch. Okay. I know my drawings are unproportionate, but if you do 1/2 plus a half is 1 inch, an inch and a half, 2 inches, and then that's 2.5 inches. So there's 1, 2, 3, 4, 5. There are 5 halves that can fit into that. You can also use division, 2.5 divided by a half, to figure out how many fit into that. So now along here, if there's 2 inches, okay, sorry, I keep saying inches, but they're centimeters. If there's 2 centimeters, a half plus a half plus a half plus a half is going to be 2 centimeters. So there's 4 halves that fit along the width. Now along the height, this is just 1 centimeter. So this is obviously not proportionate, but there's a half plus a half is going to be 1. So there's going to be 2 that fit along the height. So that means it's 5 by 4 by 2. So the volume equals length times width times height. So the volume is 5 times 4 times 2. So what you can do is 5 times 4 is going to be 20, and then 20 times 2 is going to be 40. So there's 40 of these half centimeter cubes that can fit into this figure. So the answer is 40 half centimeter cubes can fit into that. So hopefully this helps with some of those questions. I know some people had difficulties with that. If you have any other questions about any other problems that you guys were working on, just send them my way. If you could take a screenshot, that's what Lily did. She took a screenshot. She sent it to me, so I knew exactly what the problem looked like. I find that to be really helpful, and then I can make a few more of these videos for you guys. Also, you guys may be wondering, what is Friday going to look like? I meant to say this earlier. So Friday is going to be a review day for both Miss Matola and I, and it's also going to be kind of dubbing as an advisory. I'm not really sure how that's going to look, right, doing this remotely, but we'll figure something out with that. Or I'll try to figure something out throughout the week to do there as well. But mostly it's going to be like a review day, and we can kind of go over some stuff and, again, answer some of you guys' questions. I can make some more videos for you guys and hopefully clear things up. Right? It's obviously, I know it's really difficult to not have the, helping in person, but hopefully doing things like this can be the next best thing and really help you guys through this process. All right. So again, guys, those days, Tuesdays and Thursdays, are going to be really important because I only have really 2 days to do lessons with you guys that we're working really hard on those days. So again, let me know if you have any questions, and I'll be talking to you guys soon.